Hello, we are from Group 1. We'll be presenting the electrical safety test on tonometry.
Hi and Assalamualaikum. I am Sifatu Farzana. We'll be presenting on objective part. To understand the working principle and application of radio obtention tonometry. Second, to expose students to the electrical safety procedure and operation. Third, to measure different types of leakages that might occur to tonometry. Fourth, to allow students to make evaluation referring to the standard IEC 16661 and to learn and design simple testing circuit that are able to test the current leakage. For the introduction part, radio obtention tonometry is a diagnostic device that measures the speed pulses that travel within the radio arterial system and the changes they create. Radio artery is one of the branches from the brachial artery, and it is sometimes referred as the medium to assess the heart rate. For the working principle, it works by touching the sensor of the tool over the radial artery part of the wrist with the mild pressure against the flat bone. The sensor that made up of the strain gauge pressure will measure the wall deformation of the artery, and the waveform will be recorded. Waveform analysis not only indicates the central systolic and diastolic pressure, but also determines the influence of the pulse wave reflection on the central pressure waveform. For the artery with the high resistance or blockage, the pulse waveform will read faster as the diameter is smaller. So, this device will be used with the patient of the PAD, which has the blockage of the fatty plaque at their blood passage. For the medical field, knowing the arterial pressure is important to ensure the good circulation of the blood. So, we use the parameter means arterial pressure MAP. There are certain ranges that has been fixed for this MAP. So, the high range indicate that a person might be exposed to the cardiac or the kidney failure, while the low range means that the blood circulation is not good as it does not reach enough to the major organ. In terms of the safety electrical test, we have to undergo this device for the safety electrical test in normal condition and single fault condition. Normal condition is to ensure that this device is problem-free and safe to be used. While single fault condition is a test that we make the device to become the single fault condition so that we can ensure even if it has any problem, it's still safe to be used and it does not release any hazard to the environment.
Good morning, Doctor. I am Ophelia. So now I would like to present the theoretical calculation. These two figures show the human body model or level for IEC 60601-1. Here is the circuit. Show the Z input impedance. R1 equals to 10 kilo ohm, R2 is 1 kilo ohm, and C1 is 0.015 microfarad. All of it is plus minus 5% of error. In Malaysia, the standard voltage is 240 watt, and the standard frequency is 50 Hz. Hence, we can calculate the impedance Z as below. We get Z total is equal to 995.52 ohm. For the self-designed measuring device, we use C1 and C2, there is 10 millifarad built in series, and C3 is 10 millifarad that is parallel with C1 and C2. So we can calculate that total capacitance is equals to 0.015 microfarad. So moving on to the next part, how do we calculate leakage current I by using self-designed measuring device? According to this IEC recommended LCA measuring device, the voltage across the resistor for each test is measured and divided by total impedance Z to get the leakage current value. So we can get LC is equals to 50.7 microampere, enclosure LC equals to 60.7 microampere, patient LC is equal to 0.4 microampere, and patient auxiliary LC is equal to 0.1 microampere. All of this is in normal condition. Next, comparison percentage difference of leakage current values by using different device. We calculated the percentage difference by using this formula, theoretical value minus actual value divided by theoretical value times 100%. Comparison between radio and measuring device of leakage current percentage difference is 34.85% and enclosure leakage current percentage difference is 882%. Comparison between bender and measuring device. For earth leakage current, percentage difference is 12.5%, and for the following enclosure LC, patient LC, and patient auxiliary LC, all of it is 99.9%.
And I will continue for the test procedure. Our medical device is tonometry, and we need to measure the earth leakage current, enclosure leakage current, and patient leakage current, and patient auxiliary leakage current under the normal condition and single fault condition. So to conduct electrical safety test, we will be using the bender for automatic test and single test, radio 60, and our own measuring device. First, to test the earth leakage current and enclosure leakage current, we will use bender without applied part. So first, the bender safety analyzer is turned on, and the 3-pin power plug of the tonometer is connected to the bender, and we have 2 probes connected to the conductive part and the earth of the tonometer. Then, the following option can be chosen on the bender monitor to start the test. Next, to test the earth leakage current, enclosure leakage current, and patient leakage current, we will using bender with the applied part. Same as before, the bender safety analyzer is turned on, then the 3-pin power plug of the tonometer is connected to the bender, then we have 3 probes connected to the conductive part, earth of the tonometer, and the applied part of the tonometer. Then, the following options is chosen from the bender monitor to conduct the test. Next, to test the patient auxiliary leakage current, bender single test is conducted. Same as before, tonometer is connected to the bender safety analyzer, then we have 3 probes connected to the conductive part, applied part, and the ground of tonometer. Then, the option of single test is chosen from the monitor of the bender. Then the tonometer will be tested under the normal condition and single fault condition for the AC and DC. Next, for the Reader 60, only earth leakage current and enclosure leakage current can be tested. However, because tonometer is class 2 device, so there is no earth leakage current test is conducted. First, the Reader 60 is plugged in and it will be automatically powered up. Then a test lead is plugged into the black enclosure leakage probe to Reader 60 and the other end of the cable is connected to the ground of tonometer. Then the power card of the tonometer will be plugged into the socket of the Reader 60. To perform the enclosure leakage test, this button will be pressed and the test will automatically start when F2 key is selected. To test the current during normal condition and single fault condition, we can follow this sequence to have the test conducted fully. Then, after the test finish, this button will be pressed and the test will stop.
Hi, I'm Fahmi and I will talk about the test procedure for all measuring device. We will use the step-down transformer to decrease the voltage and make sure all the switches are off when we're not using it. Our own measuring device was built using different resistors and capacitors. Next, we will test the different leakage currents. And lastly, the voltage is measured and calculated using Ohm's law to obtain the leakage current value. This is the circuit diagram of our own measuring device. And this is the current setup for earth leakage current, enclosure leakage current, patient leakage current, and patient auxiliary leakage current. For results, this table shows the measured leakage current using bender without applied parts. This is for with applied parts. For the measured leakage current using Rigel 60 and using our self-designed device. This is the comparison between bender, Rigel, and our own measuring device.
Hi, I'm Ku, and now we will proceed to discussion. No values for patient leakage current and patient auxiliary leakage current in table 1 for bender and also in Rigel, as applied parts are not connected. Earth leakage currents are measured but omitted, as tonometry is a class 2 equipment which does not have protective earth. Testing in single fault condition is not carried out using self-measuring device as it is not fused, which may cause electric shock. Measurements are almost consistent across all test sequences and conditions and do not exceed IEC 60601 limits. Highest percentage difference is 882%, which is enclosure leakage current between measuring device and Rigel, while other leakage currents have 99.9% difference. High percentage differences may be caused by higher impedance in our measuring device due to externally connected voltmeter, number of capacitors, and breadboard. Also, our measuring device and bender have lower electrical sensitivity as it can only measure up to milliampere. So, we propose several suggestions to improve our measuring device. First, reduce number of capacitors to reduce impedance. We can also use less wires and use electronic screw terminal for a more secure connection.
For conclusion, in this assignment, we introduce us with the process of conducting electrical safety tests on medical equipment by using the bender and Rigel 60. And we successfully extracted important information in tonometry, which is a class 2 medical device and type CF protection class. And we also now understand how IEC 60601 acts as the standard for the safety limit and compliance of leakage current in medical device. That's all from us. Thank you.